And hello everyone, and welcome to our first webinar for the year. You've been asking for math, and here we are. We're so delighted to have you with us. I am sorry to be late. I got a bit delayed. I was trying to go somewhere else to do the webinar because my internet wasn't good. So a little bit puffy. Sorry about that. But before we start, I would like to thank the Victor and Sally Mute Foundation. The Victor and Sally Mute Foundation have been sponsoring our webinars over the last 2 years, and they have also sponsored significantly our teachers training over the last 2 years. We are so absolutely grateful to them to be able to deliver you this free webinar. I'd also like to, I was going to welcome Emma, but she had to welcome herself. We could not do this without Emma. She is our IT girl. She really does really pushes us, I think, into the 21st century. And because of COVID, we've had to bring ourselves to you as you haven't been able to come to us. So thank you very much, Emma. I don't know what we would do without you. Okay, before
Can I just ask everyone to, in the chat, can they just let us know if you're a parent or a teacher and where you're from, please?
Okay. All right, so before I go, I just want to mention to Emma that one of the people trying to join, Nicola Abraham, says that the link is not working. So I don't know if we can resend her the link, Nicola Abraham, but you won't have her email.
No, I wouldn't.
Okay.
But it is working because we have over 100 people logged in already.
Okay, let me introduce, let me just do my bit, and then I will come off and I'll call Nicola and see what I can do about that. Okay, so before I introduce Dr. Sharon Jagannath to you, just have a few house notes. We will have a Q&A session at the end, and we're asking you to use that Q&A button. So if you notice that you have a chat button and a Q&A button, if you ask the questions in the chat button, it's going to get lost in the chatter because the chat just rolls up. So please remember, if you have a question, to use the Q&A button. Also, we are going to try to get around to as many questions as we can. If we don't get around to your question, please email us. You all contact us by email, so you know, info@dyslexiatt.org. Pose your questions. And Dr. Jagannath says if we send her the questions, she will spend the weekend trying to put some answers together for everyone. So without further ado, I would like to introduce Dr. Sharon Jagannath. Sharon. How are you? Thank you so much.
Hi, good afternoon.
Doing this for us.
Well, thanks so much for this opportunity.
Ooh, I am on somebody else's computer and something has happened. Okay. Well, Dr. Jagannath, I am so delighted that you could join us today. Dr. Jagannath is at the Faculty of Education at University of the West Indies here in Trinidad. She has spent a long time teaching math in schools, but also she now spends time with practicing mathematics teachers and prospective mathematics teachers, training them in mathematics. We're really looking forward to this webinar, Sharon, and without any further ado, I am going to just put it over to you.
Thank you, Catherine. I will begin sharing as I speak. I'm so pleased to be here today, and working with teachers is my passion. So is working with teachers who are parents who teach math. So I'm really happy to be here today to be able to, please let me know if you see my screen.
Yes, it's up, Sharon.
Okay,
yes.
Great, thank you. I'm really happy to be able to share some of my learnings as a math teacher, a teacher educator, and a researcher in education, having worked with both primary and secondary school teachers and children and schools. So today is a really welcomed opportunity for me to share what I've learned even through my own professional development about teaching math. So without further ado, our focus today will be to just briefly talk about the difference between math difficulties and math learning disabilities, because today's session is not about what we would call a learning disability, but some of the difficulties that students encounter with math in the classroom and outside. Also to talk about the link between numeracy and math difficulties, and to just explore 6 math difficulties that I've identified from the research that has been done already and from my own experience and experience of teachers that I've worked with, and to explore some practical approaches to dealing with those difficulties, right? So, question, why do people struggle with math? I mean, we use math every day to solve everyday problems, yet so many people struggle with it, and sometimes for their entire lives, to the point where they develop math anxiety. I mean, one factor that contributes to people's prolonged struggle with math is our society's high focus on high-stake exams like the SEA, the CSEC, and the CAPE, and the opportunities that are opened up or closed off to people. And really, it's very easy to blame teachers for students struggling and not doing well, but there are so many other factors to consider that contribute towards the difficulties that students experience with math, learning math and doing math. One of those factors is that math is a complex subject. So at school, we learn about number, we do arithmetic, we learn algebra, geometry, statistics, and so many other things. And we expect that after studying math at school, we should have a sense of quantity. We should be able to decode mathematics symbols that we see in problems and in other places. We should be able to quickly retrieve those math facts that we learn from our memory. We should be able to use our visuospatial skills to interpret information that we see. And of course, we expect to be able to reason logically. But those are things that we have to learn to do. And then we turn around and expect children who leave school at whatever level to be able to think carefully, logically, systematically, critically, and creatively, and even efficiently. We expect them to be able to make reasoned decisions and to be able to solve all sorts of problems. But some students encounter obstacles that interrupt their learning process. So there's a gap between what they should know and should be able to do and what they actually know and can do. And sometimes those disturbances occur in a child's brain. For example, they may struggle with reading. They may have trouble interpreting space and diagrams. There might be disturbances in how they receive and process, store, and even retrieve information. And of course, how they reason and organize their thoughts. And these areas of disturbances in the brain contribute to dyslexia and dyscalculia. So we're not going to talk much about dyscalculia today, but it is the same areas in the brain that affect children's ability to work with letters and words, affect their ability to work with numbers and other things that go with numbers, okay? So how does dyscalculia affect math? Well, it's associated with persistent brain differences that result in weaknesses in number representation and processing. And these differences actually can't be explained by their intelligence, their development, their age, their education, or their socioeconomic status. So it's something that is physiologically at play in the brain. Now, there are resources for you on how you can try to detect a child who's at risk for dyscalculia. Dr. Stephen Chin has created a checklist, and he teaches a lot about dyscalculia around the world. His checklist is available on the internet. for use by teachers who are interested. It is not a formal diagnosis, but it allows you to have some resource that you can use to identify a child who might be at risk for dyscalculia, a difficulty with math and numbers that is beyond what they are learning in school and at home. So how you can actually know for sure requires a diagnosis from a professional who's trained to do that, a full evaluation. And some of you might already know that the Dyslexia Association offers, helps you find people who can diagnose for other types of learning problems. So there isn't really a test for dyscalculia, but it usually turns up when people are evaluated for dyslexia, for ADHD, and other kinds of issues, things that children struggle with, or even adults. So it really requires looking at what a child has been, or a person has been experiencing for a prolonged period of time, especially when there have been many interventions put in place and they have brought no change to their status, their difficulties with math. Okay, now there are other reasons that people struggle with math. I mean, what do teachers see in the classroom? They see children who act like they're not interested in learning math. Some of them act out in class. Some of them don't do their homework and classwork. Some of them skip class, and with the older children, they skip school too. They just don't know how to think about the math that we ask them to do. And sometimes that reflects a negative attitude towards maths. And it's because of what they have heard in the home. Sometimes it's because of what they experience at school. Sometimes they just don't have the foundation to progress because of poor teaching. Now, again, we say in these poor teachers, but teaching for one child that is good might not be good for every child, because children learn differently at different rates in different ways. They respond to different stimuli. And if there's an opportunity for differentiated instruction, then maybe we could reach all learners in a classroom. But until that is so, the best teacher can still lose some students, and there are students who will struggle with math, right? So it then falls to their teachers to help them. And who do I mean by teachers? It's not just the adults in the classroom at school. It's the parents, the siblings, the guardians, the aunties and uncles and cousins at home. All of us can work together to help students who struggle. So it's not just about the classroom teacher. We are all teachers to students who struggle, because these students need to know that their teachers will take time to get to know them. They're interested in helping them succeed. Their teachers create a learning environment that stimulates their interest in learning math, will actively engage them in learning, use evidence-based instruction to reach them, and of course, expose them to strategies that will support and reinforce their learning. And learning in this case, we're looking at not just numeracy, not just problem solving, but the use of math language. And we want to put all these things together. How do you do that as a teacher in the school or a teacher at home? It's a challenging task, okay? And it bothers so many of us when we see children not succeeding. We know it's painful when we know that they're struggling, okay? So from here, I just want us to talk about numeracy, because it's become a buzzword around the world, and certainly here in Trinidad and Tobago, and you'll be hearing more about it from the Ministry of Education as time goes on. So numeracy refers to all the knowledge and skills, behaviors, dispositions, and capacities that students need to use math in various situations. So it's different from being able to just do math in the classroom. It's different from being able to answer those questions, those exercises in the textbook. It's about being able to transfer that knowledge across situations. So being numerate means that you can readily interpret information, presented in charts, in diagrams, in statistical data. You can process numerical information. You can solve problems that require maths, and then check your answers to see if your solution is right. You can even understand and explain your solution to others so that people know how you have gotten there. And of course, you should be able to make decisions based on logical thinking and reasoning. So being numerate is very big. It's huge. And we must all work together to develop numerate citizens, right? Problem solving and decision making through thinking. So we should leave schools numerate and prepared to function in the world. Learning maths at school should not just focus on passing an exam or winning a scholarship. And I mentioned scholarships because scholarships were recently announced. And I don't know if you know, but the Ministry of Education, not that I'm using this as a benchmark, but they have reported that on average, the CSEC math score has dropped from around 61% in 2015 to 54% in 2020. What is happening? Why is this happening? It might be related to the fact that more students are struggling with math than we really know. And perhaps they're struggling because they're not learning how to see math at work in real, tangible ways. They also need time to master those math skills that we are teaching them. Okay? Now, I'll move on to talk about some areas of difficulties. And the truth is, there's no one reason why students struggle with math. And the factors that I will expose you to are not exhaustive. It's just those 6 ones that I've pulled out, because we really need the home and the school to work together to help children overcome their struggles. And so the strategies that I will expose you to today can address one or more of the problem areas that I will highlight. And as I explore each strategy, I will tell you exactly where I see them fitting. So let's talk about number sense. And that refers to the skills that allows automated understanding and use of numbers. It actually develops in early childhood. And if it's not properly developed when children are young, they struggle with using numbers for a great part of their life until it is deliberately attended to. Another reason is that they have problems recalling number facts, or in my day we call them number bonds, which are just arithmetic relationship between numbers like 2 plus 3 is 5, 1 plus 4 is 5. Those are number bonds and number families. Of course, they struggle with math, language, and vocabulary. Math has its own language. It has words, numbers, symbols, and language structures that we must be able to use to communicate properly and to solve problems. We also find that students struggle with fluency, and fluency has a big meaning, but basically it's being able to recall math facts readily and apply them to multiple situations using various representations, and of course choosing the best strategy for solving problems. But children struggle with this. The next issue is mathematical reasoning, which is a process. It's not just something they do, it's a process of applying logical thinking about a problem to identify the best problem-solving solution and then following through to a solution. So that brings us to problem solving, something that students struggle with from young all the way up into university and beyond. Problem solving as well as a process of identifying and applying appropriate math knowledge and skills to answer a question. And here's the kicker, for which an answer is not readily available. So many of those things that we call problems in a textbook, exercise 5B, there's a reason it's called exercise, because those are exercises and not problems. Problems are really things that require deep thinking. Okay, and problem solving begins with analyzing a problem And struggling students need help learning how to analyze a problem, identifying the type of problem it is, so that they can choose the appropriate solution for solving them. Of course, problem solving requires reasoning and fluency. And reasoning and fluency require number sense, the ability to retrieve maths facts, and the familiarity with math, language, and vocabulary. So as I said, these areas of difficulties, and the list is not exhaustive, but you can hopefully see how these areas tie together, where they all are integrated and all depend on each other, working together. So today, I will suggest some evidence-based strategies that can be used with individuals or groups with differentiated instruction. Of course, my target today really is those students who struggle, and they may just be one or two in a class, one in your home even, and they may need careful management and support. So these strategies have been researched in classrooms around the world and even here in Trinidad and Tobago, and have yielded success for struggling students. So these strategies really make learning a positive experience. They encourage persistence. They try to demystify problem solving, and they can, as I said, they can be used with individuals or with groups. And of course, they are based on empirical research. So let's do some math. Tell me, I'll give you a half a minute to get a pencil and paper and just jot down how many you see. I'm going again. I hope you got that. Hopefully you saw 1, 2, 5, and 8 in those little groups. And if you had been able to identify the number of objects there, you were able to sensitize, which is the ability to identify the number of items in a small group without counting. It's said that babies and animals can sensitize up to 3 objects, and adults can sensitize up to 5. Of course, it takes a little bit of work and developing your number sense to get you from 3 to 5 in your sensitizing ability. Now, to identify those 3 groups at the top, you would have used perceptual sensitizing, because you are by now as adults familiar with these kinds of groupings. Maybe you would see them at playing cards or dominoes or dice, right? And for the second group at the bottom, you would have used conceptual sensitizing, where you actually use perceptual sensitizing, recognizing 2 groups and putting them together to make that bigger group of 8. Okay, let's do some more. So write down your answers. Which line is longer at the top and which group is smaller at the bottom? Quick, 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 not giving you much time. You should be able to do this quite quickly. Y'all are grown. Now, would it surprise you to know that the lines are actually the same length in terms of the number of objects they contain? And the groups have the same number of items altogether. And you probably use visual mapping. If you were able to tell quickly and readily that the 2 lines had the same number of objects, you probably use visual mapping to map the dots and lines 1 and 2, and probably sensitizing to quickly tally up the numbers in the groups A and B. Yeah? Here's another one. What does this mean to you? And write down the first thing that comes to mind when you think of what this symbol here means. Now, did you see it in any of these ways? Did you see it as the cardinal number 27, meaning counted value of 27? Did you see it in groups of 10s or groups of 5? Did you see it as the ordinal number 27, or in some other way? Now, children with, oh, one more, I forgot about this. Quickly write your answers to this, which is going to take half a minute or less. This is mental math. So adults, we should be quick at that. So let's go. Did you get these answers? Now, there are many children who struggle with all of those things that I just asked you to do. And there are adults as well who struggle. Maybe some of you here. I wasn't trying to embarrass you, just to show you how we take so many things for granted. In fact, children who struggle with number sense or who have poor number sense who struggle with these tasks. And number sense is really just a general intuition about numbers. And of course, many of those children who struggle with math, even the older ones, but especially younger ones, have poor number sense. And number sense is something that you learn. It's not something that you just have naturally. Some of it you have naturally, like supertizing and recognizing small quantities. But other things that are encompassed in number sense, you must learn. So for example, people with poor number sense have difficulty counting, estimating, ordering quantities, writing numbers, performing computation or doing arithmetic, remembering number facts, and sometimes they count on fingers. And I'm saying that there's absolutely nothing wrong with counting on fingers. Our brains all work differently, right? Now, from here, I'm going to talk now about those strategies that we can use to address some of these problem areas. First one is about practicing basic number facts. Now, drill and practice has really gotten a bad name over the years. But how else do we learn things? How else do we put things to memory? Drill and practice is only meaningful though if children have or students have already learned the basic number facts conceptually. If they don't know that 2 plus 3 is 5 and have a clear understanding that 2 plus 3 is 5, then you could drill them from now until kingdom come. They will struggle with 2 plus 3 is 5. But once they understand the number patterns that generate number facts, they could do almost anything. In fact, they should spend 10 minutes every day practicing number facts or arithmetic facts at home and at school. When I was in primary school, we had tables on mental and we did drills on a regular basis. Now, there are many games that you can use and you can adapt to help develop, help students rehearse or practice number facts. Let's think of Go Fish, for example. You can actually change the rules of Go Fish. So you can decide to work on number 10. And what you would do is remove all the 10 cards and all the face cards, but not the ace, so that whatever cards are left can actually be used to make up 10, like an ace and a 9 card, or the 3 card and the 7 card. And then you can play with your child, or you can let children play together, or groups can play this modified version of Go Fish. And in fact, games like this could become part of family game night. Change the number that you're working on, adjust the deck of cards, and play a game. What about snakes and ladders? I don't know that children still play these games, but you can actually modify snakes and ladders. So for example, you play with 2 dice. A player can only move if the dice, the dots on the 2 dice add up to a specific number, like 10 or an odd number. Play with 1 die and change the rule so that you could move only if you get an odd number and you move that number of spaces. This helps with supertizing. It helps also with learning number facts. Change the rules again so that the player moves with the 2 dice. They move either the sum or difference or product of the 2 numbers on the dice. What about a game of memory? Remember that card game where we used to lay out all those cards on the table and pick pairs, and if you get a matching pair, you keep it? Well, you could modify it and use cards with different information on them. Some cards could have the numeral, some cards could have the number name, another set of cards could have the group of objects up to what the child can count, right? And a player can keep the pair that they turn over If they can correctly find the sum, not just matching a number name to a numeral, but if they can correctly compute the sum or the difference or the product or the quotient, yeah, you can even tell them they can keep their card if they could correctly predict whether the second card is higher or lower than the first one. So there are ways that you can modify these games, these little games that children play. Dominoes as well helps with subitizing, but it also helps with pattern recognition and generation. For example, here, the first 4 dominoes have been given and the child is asked to search the pile to find the next 2 in the sequence. You can use multiple dice to have children make different digit numbers. Each color represents ones, tens, hundreds, and so on, even with decimals, that they can make different numbers and tell you what those numbers are. So using dice can also reinforce number formation, number grouping, number patterns, and of course, as I said, reinforce or develop that subitizing skill. I mean, these games, these silly little games can really help struggling students. And remember, I said that today my focus is on those students who struggle, not the ones who are not struggling, although they can benefit from the reinforcement, but particularly those who are struggling, okay? And these games help develop their number sense, but it also helps develop their fluency, reasoning, and problem solving, because remember, those 3 things rely on number sense to some extent. Now, here are some other games that children can play to develop their number sense. And some of you may have these games at home. Here are some websites that can help children practice number facts and develop their number sense. So many resources out there for us if we just look. Now, some of them are free, some of them you have to pay for, but there are resources out there for all of us, okay? As we see here. Now, the next strategy that I'd like to talk about is building vocabulary. And, you know, words and meanings is vocabulary, but words and vocabulary, words have different meanings in different contexts. For example, children have to know what odd, even, average, sum, denominator, variable, expression, data, convex, polygon. They have to know what these things mean. So they need math vocabulary to be able to understand and follow verbal instructions and give or understand explanations. They're never too young to learn big words, right? Words that are level appropriate. There's nothing wrong with using the word convex, right? And you should encourage them and you should use with them the correct math vocabulary. Their minds are open. They can absorb many, many things. And it's especially important for them to learn the vocabulary for when they are explaining their working. You know, we like to call them up on the board or ask them to tell us how they did it. We don't just want to know how they did it. We want to know why they did it. So they have to be able to have that vocabulary to communicate effectively. So what do we use then to develop their vocabulary? Simple things. How many of you have seen these things around? Other things? These baby toys, you can use this to have students order the rings by circumference or diameter, or identify which is the biggest, which is the smallest. You can play games like charades, modified again, where they draw or act out clues to some skill or concept. They can play Scrabble related to some topic or concept you're teaching, and so they form words related to that. Of course, that also practices their arithmetic because they are adding up and scoring. You can create crossword puzzles and word searches using vocabulary related to a particular topic. You don't always have to give them a definition and words and meanings and that kind of thing, right? Hangman is another game that you can play with math words and phrases. Of course, you can have them make a math dictionary or encyclopedia where they write words or phrases with meanings and examples of how they are used. And because we have access to technology, some of them may even be able to put pictures in those dictionaries and encyclopedias. Encourage them to make flashcards to help them learn. You can help them create word walls as well, related to different topics, concept maps, things like that, right? You can play Jeopardy. Have them guess the word if they're given the meaning. The possibilities are limitless. And this approach helps them learn and develop their math vocabulary and communicate mathematically. It also supports retrieval of number facts and their application to problem solving. Now, you can find vocabulary games online as well. So this is just one example, okay? Now, the next strategy I call sensitize it, because from birth, children have physical experiences with math, yeah? And when they get to school and they no longer have these physical experiences, they begin to struggle with the language and with the procedures in math. And prematurely exposing them to visual representations or symbols can actually slow down their learning. And I'm sure you would agree that humans learn best when all our senses work together. So exposing students to multisensory instruction or multisensory teaching and learning really enhances their learning experiences. And Jerome Bruner was one of the earliest promoters of multisensory approaches. So I just want to play for you a short video clip about
multisensory math is the use of sight, touch, hearing, and movement to make it easier to understand what quantity and symbols represent. Numerous studies have shown that multisensory math instruction is good for all learners. It can really help kids with issues such as ADD, dyslexia, dyscalculia, poor memory, auditory issues, math anxiety, repeated failure, and diminishing confidence.
Yeah, and I'm sure that you have recognized some children that you know who may be struggling in some of those areas. Not all of them have ADD and those sorts of things, but when they're struggling, they're struggling. And Bruno also made this CRA approach most meaningful. Now, multisensory instruction really begins with teaching through concrete manipulatives, which are just those physical objects that children can touch, they can move, group and regroup, disassemble and reassemble differently. But of course, teachers need to demonstrate to them how to use these manipulatives for them to really benefit. And then struggling students in particular can progress more readily to visual representation. So they make it with the blocks and then they draw it on their paper. Yeah, and then they are ready theoretically for abstract thought. The problem is that research has shown that children become capable of abstract thought by the age of 14 or 15, which is about Form 3, maybe Form 2, maybe Form 4. But we are expecting primary school children to get to abstract thinking by the time they are 9, 10, and 11, okay? Now, there are implications for what we do as teachers in the classroom, in primary and early secondary, even advanced secondary, because as I said, children progress through these stages at different rates, and we can't predict from one child to the next who is going to need support in different areas. So be patient with them and meet them where they are, okay? Now, there is some new research that has moved away from this linear movement from concrete to representational to abstract. And it suggests that when students interact with these different forms of representation simultaneously, that they progress a lot more quickly. Yeah, they become more independent of the concrete and visual representations and move towards abstract thinking. Of course, if they are ready, if they are struggling, they may be stuck on the concrete and visual representations longer than those who are not, okay? So I do have this video, but I will, instead of playing it, I'll take us through some of the pictures that are shown in this video. So for example, in this method, you can see that on the extreme left, there are blocks, well, a representation of blocks. So children are exposed to those 10 blocks, and they can build numbers as they move along. And while they are building numbers, using their hands to touch and move and flip and fit together, they are drawing in their books what they see. Doesn't have to be an exact replica. And we want to use the word model and not draw, because sometimes you tell a child draw it and they want to draw every detail. What we really want them to do is to model it or represent it visually. So they work with the blocks, and while they're working, they are illustrating or modeling what they see in paper. And then at the same time, they are learning the numerals for these numbers. So they are learning how to write 43 and 33. So they are working with the blocks, representing it in their book in a model, and then they are writing the numbers and learning the vocabulary for 43 and 33. And you can use this approach for all sorts of things. For example, number facts, building number families. Children see those groupings in different ways. Here's another one, using an area model, where they use the concrete blocks, they put them together to work out their area, they draw what they see, and then they write the numbers and write down the calculations. Yeah, so recent research is showing that that approach, simultaneously exposing them to these different representations, is more productive, particularly with students who are struggling. Because some of them get stuck in the concrete mode, and then if you move on to representation, they get stuck behind, they get left behind, and they're struggling. So if you expose them simultaneously, there's a better chance that they can transition more readily. I mean, they might still be stuck on the concrete and visual representations, but at least they would be learning conceptually. Okay, now what are some multicentury resources? Look, you have these things around. If you don't have them, you might be able to find them. Pipe cleaners, music, textured object, base 10 blocks. You can even use Lego blocks as base 10 blocks, okay? Look at this example, using transition language. So instead of describing 10 plus 1 group of sticks, you describe it as, instead of describing it as 11, in the meantime, you introduce it as 10-1 instead of 11. So they understand that this is 10-1 and eventually gradually move to 11, the proper name. 10-2 as the transition language. And then 2-10-1 for 21. So conceptually, they're understanding that 21 is 2 10s and 1. Okay, so you can use that approach to gradually move them from the concrete to the abstract, which is the proper number names. You can use chains and strings. You can make these by different colored beads, by strings. You may have thread and yarn and that kind of thing. You change the grouping depending on, for example, if you're learning tables, depending on the number that you're working with. Another way to use this is making these bracelets or loops, and you change the number of beads based on the number that you are working on. If you're working on 7, then you have beads that have loops that have 7 beads. What about tangrams? You don't need to buy a tangram set. You can make a tangram. You can have them make tangrams with you in the classroom. You can use tangrams for teaching about symmetry, congruence, similarity, polygons, conservation of area, transformational geometry, lots of things that you can use this single resource to give those students the concrete experience and that they draw and then move on to the abstract experience, okay? I actually did this little quick workshop. I suggest that you look it up. You'll get all these resources afterwards, and I got a little certificate, as you can see on your right side. It's a really nice little course, and it introduced me to a lot. I learned a lot about multi-century math last year. So here's some other things. Understood.org is a really wonderful website. It focuses a lot on dyslexia, but there are resources for dyscalculia on it. And dyscalculia really is about mathematics difficulties. And so even if your child does not have dyscalculia, you still can benefit from looking at these websites. Now, I was involved with some research using the CRA method for trigonometry. This teacher went and bought her resources. She had pencils, she bought these little craft sticks, she made her holes, and she used them to teach trigonometry all the way up to angles of elevation and depression. Yeah? So you can use these things even with older children. Here in primary school, I was involved in another research project that worked on geometrical concepts using tangrams and origami. And children had fun. They worked in groups. They came up with lots of interesting things. Yeah. And here's a quick method of, with respect to algebra, using algebra tiles. Those squares and rectangles on the left represent algebra tiles. Solve the equation. Quite often the teacher stands on the board and tell children, do this, do that, next step, next step. So instead we have them build models. We take the algebra tiles and we rearrange them. You introduce language here. These blue circles represent adding the additive inverse on both sides. Too many teachers telling children carry it over the equal sign and change the sign. That don't make sense. How could that make sense? Use the language. They learn about additive inverse in primary school, reinforce it in secondary school. And we move on. The algebra tiles, the red ones cancel the yellow ones. And so what you end up with is, notice the equation solving on the left that you probably were typically exposed to in school, but on the right, we're seeing how those algebra tiles work. And then we distribute and share. Yeah? So you can use the CRA approach in many topics that you teach in math. Yeah, children responded quite well. Now, moving right along, there are other strategies that can help them with their thinking. Strategy number 4 is graphically organizing. So for students who struggle with math, reading can be confusing because they need to sift through and organize information. They need to identify relationships and use them to solve problems. They need to select those strategies. They need to be able to communicate their thinking and to reason. And they need visual maps like graphic organizers. And I'm going to give you some examples of graphic organizers here. Notice that there are websites here. As I said, you'll get all these resources. So graphic organizers really support schema-based instruction because students can use them to record and track their thinking in preparation for problem solving. So they help with problem solving, but they also help with preparation, analyzing a problem and so on. But they have to be taught how to use them. Now, the teacher can explain how to transfer the information from a given problem to an organizer. And students can practice filling in the information on it, and then they take it away. They have it there, it's theirs. Graphic organizers can be used for multiple examples of the same thing, so that you compare these, as you analyze different types of problems, you compare them, look for similarities, differences, and patterns. This helps the teacher also see where problem solving breaks down, which is usually at problem analysis stage. Students have them for reinforcement and reference as they learn more. It's their takeaway. So they help develop students' number sense, number facts, vocabulary, patterning, reasoning, fluency, and problem solving, especially with word problems. And as we get to word problems, we come upon the next strategy, which I call talk it out. Now, allowing students to talk in class can generate a lot of noise. And I know teachers hate noise, they hate losing control, and they hate losing their cool. But encouraging students to talk tells you a lot more than reading what they have written can tell you, right? Think alouds can be really helpful because students talk through their thinking as they solve a problem. And hearing their thoughts can develop their metacognition, which is their ability to think about their own thinking. Now, if you are working with a student one-on-one. Hearing their reasoning can also help you identify their misconceptions, because it's making their their solution strategy explicit. And besides, too often the only voice that we hear in the classroom is the teacher's voice, right? And our culture is traditionally oral. So students can learn from each other, of course, under the right conditions, right? Now, think pair share is another strategy that allows students to interact. Yeah, there's a level of social learning that happens when children interact that helps develop their confidence. And if you stick in writing there and you encourage them to write down their thoughts, not just to share, not just to think and share, but to actually write, then they have that takeaway to further reflect on what they do. And it also shows you where their thinking is breaking down. Yeah. And when they work in flexible groups, you group them based on what you know about them, their disposition, what they are like, what kind of support they need. It brings that opportunity for peer tutoring. Now, talking about math develops not just number sense, not just practices number facts, but develops vocabulary and communication and reasoning mathematically. And of course, that strengthens their fluency and problem solving. Yeah. Our next strategy I call modeling thinking. Now, how can you show someone how you think or how to think? Well, using read alouds is a good start, because if a child can listen to you read, they pick up where your tone and pace have changed, where you pause, where you emphasize. It gives them cues as to what information is important and what isn't. Yeah. It also helps them develop their listening skills, because, a lot of children don't really listen. Not that they don't know how, they choose not to, but because it's not a skill that is practiced. We can use think alouds, which is where the teacher verbalize your thinking and reasoning during problem solving. So it's think alouds on the flip, on the reverse. It's not that they are thinking aloud so you can hear what they're thinking, but you are talking through what you are doing. You are modeling how to think. They hear your voice while they think through problem solving, what strategies you consider, which one you choose and why. They can follow along step by steps, and they learn how these different steps connect with each other. They hear you speak the language of mathematics that builds their vocabulary. And of course, it eliminates all guessing about what you're doing. And this is called explicit instruction. Now, I don't usually advocate explicit instruction as a general strategy, but for children who are struggling, for all the various reasons we listed above, explicit instruction might be the only way that they learn how to analyze a problem and work through an algorithm. Yeah, teaching, they can learn how to think by logically modeling you, but modeling is not enough. They must also be able to work alongside you and tell you what to do. And that tells you what they understand and what they don't understand. Yeah. And then they should be able to work on their own, but with you on their side for guidance. That's what we call guided practice. And then, of course, they should eventually be able to work on their own, independent of you, but under your supervision, so you can offer feedback readily and help them keep on track. And we call that independent practice. Now, this approach is especially effective for students who struggle with working memory. Explicit instruction really facilitates that repeated practice that helps with memory and retrieval from memory. And of course, that builds fluency. And it helps with multi-step problems. And this takes us to our next model, what I call schematize it. And this is especially for word problems, because students struggle with word problems all the time because of the amount of reading comprehension it requires. And they don't know how to analyze a problem. So they need to be taught. So what is schema-based instruction? Well, students must understand the language that is embedded in text. And as I said before, they have to sift through that information. And that's where many of them get stuck. Sometimes they lack the pre-knowledge or have poor numeracy skills. What if they have brain disturbances? Solving word problems requires them to pull information from their long-term memory to their working memory, or what we call short-term memory, right? So an effective way for solving word problems is schema-based instruction. Now, Jean Piaget had defined a schema as a cohesive, repeatable action sequence possessing component actions that are tightly interconnected and governed by a core meaning. So a cohesive, repeatable action sequence possessing component actions that are tightly interconnected and governed by a core meaning. And teachers can help students develop schemas for different types of word problems. And what we mean by schemas, it's really the underlying structure of a problem. And that's what the schema is. If you learn the schema, then you understand its underlying structure, and you can classify problems by type. Now, again, I don't really advocate this. I prefer conceptual teaching, but for students who struggle, schema-based instruction really is an efficient approach to teaching them how to solve problems. Yeah. And of course, this brings us back to explicit instruction. So it's another way of using it, explicit instruction, and there's nothing wrong with that. And again, students can compare multiple examples of the same type of problem, look for patterns so that they learn the schema. When they have learned the schema or the underlying structure, then you can teach them different strategies to solve it. Of course, it's important to reinforce the vocabulary and the language of math with each strategy, but it really helps students analyze word problems and identify strategies to solve them. Visual cues are also helpful. So those charts that we see all over classrooms, some children need them. And students can make their own at home, or make it in class, or draw it in their copybook, and they take that home. Mnemonics are another approach. I'm sure you would remember BOMDAS or BODMAS or PEMDAS, SOCATOA from secondary school, and trigonometry, and STAR is a problem-solving acronym. Of course, the downside of this approach is that some students struggle with moving on from the schema that they have learned. So they've learned schemas 1, 2, 3, 4, and that's all they know how to do. They can't progress further. So what then do? We move schema-based instruction to schema broadening instruction. So they must learn how to transfer what they learn, the schemas that they learn, to new problems. And it's especially important for when the information they're presented with on a problem comes in a different way from how they learn the schema. So they have to learn to manage extraneous information. They have to learn strategies like crossing out irrelevant information to simplify the problem. Circle, highlight, or underline the important information. And we have to teach them how to modify their schemas to new problems. So it's not that they just do it on their own. We have to teach them how problems can change and how to change their schema to suit the new problem. We also have to teach them how to combine schema for multi-step problems. Yeah, and this approach really helps develop their vocabulary, their reasoning, fluency, and problem solving. I mean, why are we learning maths? Not to solve problems. So if we do all these things to help them build vocabulary and number sense and all that, then we're really taking them closer towards problem solving. And that brings me to the next strategy, to teach problem solving. Now, we don't really teach generally problem solving as a rule. We teach how algorithms, how to do this, how to solve that. But that process of moving through this cycle that George Pollier talked, and understand the problem, make a plan, enact the plan, and look back, we don't really take them through that. We don't teach them, generally speaking. And of course, the last step, evaluate or look back, that we certainly quite often forget. So they go through the 3 steps and they're done. But most of them don't even get through step 1. Yeah, and I mean, each of us interprets and processes information differently, right? So it means that we might have different ideas about problem solving. So it's important to explore problem solving approaches that your children are suggesting, because they could be on the right track. And if they're not on the right track, then you help them figure out, probe why, help them figure out what they can change and what they're doing to get to the right answer. Now, I'll give you a personal story. I've always struggled with arithmetic, and I'm not ashamed to tell you that. Right now, I can't tell you what 7 and 9 is off the bat. 7 plus 9, I have to think about it. I have to say, well, 7 plus 10, take away 1, or maybe 7 and 7 plus 2, right? I have a maths degree. I always struggle with remembering what multiplies to give 56. Right now, I'm not sure if it's 6 and 9 or 7 and 8 or maybe something else. Yeah, and I even have to tap on the table when I'm adding numbers, sometimes tap the 5 pattern or the 4 pattern. I don't count on my fingers, but I have found different strategies. So why should we discount these strategies? Because there might be strategies that we think are more efficient. They might be more efficient, but for children who are struggling, we need to meet them where they are and get them, if possible, to the efficient strategies. Yeah, so teaching problem solving is an important thing to do. And part of teaching problem solving is teaching about problem solving strategies, multiple strategies, so that they have a whole arsenal of things to choose from. Yeah, even if the strategy that they choose is not the one that you choose. So again, encourage, think aloud, so that you can understand how and why they came up with the strategy. If it's wrong, you ask them questions to figure out why it's wrong, what they were thinking, and then you help them see how they can correct it. Encourage them to stick with problem solving. And here is where explicit instruction becomes very important for struggling students. Encourage them to explain their strategies. This will help build their confidence and their communication skills. If they share their understanding in a group or in a class, then maybe other children can learn from them. Now, there's so many different problem-solving strategies, more than these here on the screen. For example, guess, check, improve, and repeat. Visualize as they read. Visualization is a skill, and I know dyslexia does some work with visualization. Allow them to create models. Why must they only work with equations? Why can't they not use manipulators? Remember, we're talking about children who are struggling. We want to explore them to multisensory teaching and learning so that they can move from the concrete to the representational to the abstract, but some of them take some time. Help them learn how to find schemas. Help them learn how to use graphic organizers. Help them learn how to look for patterns in problems. Now, this is not an exhaustive list. It's the 9 problem-solving strategies. It's not really only 9. These are 9 in whatever context, right? So you also have to remember that they have their own ideas. And of course, teaching about problem-solving really develops their reasoning and fluency. Yeah? Now, I know that everybody's concerned about children passing exams for different reasons. I'm concerned about it too. I have a niece writing SEA just now, right? And a best friend whose daughter's writing SEA too. But above all else, learning math should help prepare students with the ability to use and communicate information efficiently, to think and reason logically, creatively, and even critically. They have to learn how to do that. They have to learn how to make good decisions and solve problems, because they have to function in a natural world. And I want to remind you of something that I remind my teachers of every time I meet a new group of teachers. We do not teach math. We teach people how to do math, because they need it in the real life. We do not teach math, we teach people. Little people, big people, yeah? And the skills that we supposed to provide them in a math lesson is supposed to help them function in their everyday life. So, as I close, I just want to give you some working tips for students who struggle with math, because it can be daunting for them and it can be daunting for you as the teacher or the parent looking at this child struggling and not knowing what to do. There's so many things that you have around your home. Yeah? Some of you have material that you can make things, or encourage your students or your children to help you make things. Some of them you can buy. Use the technology that's available if you have access to technology. There's so many things on the internet that are for free. Of course, you have to be discerning when you select these things, and there's some things that you can buy. But focus on making math real to students. Yeah, use objects and problem context that they're familiar with. Don't tell them about snow. Some of them don't know what snow is except on TV. You know, but we have a rainy season and a dry season. So you could talk about those things when you're looking at graphing, looking for weather patterns and so on, right? Celebrate their wins and help them over their hurdles. Yeah, work on building their self-esteem by supporting them. Now, I hope you found this information useful, and just as I end, I want to help pull it all together for you. So here are some useful tips based on what I shared with you today. Deprioritize mental math. Remember, we're talking about struggling students. Deprioritize the mental math, but practice supervising and the maths facts, right? Vary your instruction. Sometimes multicentury, sometimes explicit, sometimes schema-based. Well, I guess basically all of it is explicit, right? Teach problem solving, the problem solving process, and problem solving strategies. Practice read alouds and think alouds because it also helps them learn vocabulary. Don't be shy about using graphic organizers. Make handouts for them. It's maybe just one or two in a class who are struggling, or one in your home. Make worksheets. Make those little charts and flashcards. So encourage them to do it. Encourage them to talk about math. Play games with them. Make it a family affair. Use the technology. We just went through 2 years of COVID. We've been online for 2 years at least, right? You know now that there's technology that you can use. You can find it, and there are lots of things available online. Of course, keep your expectations realistic. They are children. They learn through their senses. We have very high expectations of them. We can move them from point A to B. Even those who have dyscalculia have learned strategies to help them do math and to cope in the real world. So keep your expectations realistic. And one more, reach out for help when you need. So I thank you. I end my presentation and I turn you back over to Catherine.
Thank you very much, Sharon. That was wonderful for me, a non-math person, a bit daunting towards the end, but I don't actually have any questions right now on the Q&A, but I have a question for you. I just feel that sometimes we have to separate the concept from the arithmetic. So a lot of my dyslexic kids have trouble with their number bonds or with their tables, memorizing tables. And I try to ask teachers, if you're teaching, say, multiplication, how to do it, or long division, why can't they have the multiplication tables on their desk? Because you are teaching a concept at that point. I mean, eventually these children will be able to use calculators, surely. So I just wondered what you thought about that. You're teaching a concept.
Yeah.
How can't we help with the arithmetic?
Yes, and I had made that point that they can't retrieve number facts if they haven't learned them conceptually, or at least they can't readily access them. They can remember some and not the others. Now, I wouldn't say that my primary school teacher didn't teach me well. I just struggle with some of the arithmetic, right? But the CRA approach really is helpful. So think about building tables where you have children count out 6 buttons or 6 sticks or something, and they make a group, they use a rubber band or something to form a ring around this group of 6, and they draw in their books a circle with 6 balls in it or 6 strokes, and they write next to it, one group of 6, or 1 times 6 is 6. They then form another group with a rubber band and 6 buttons or whatever the resource, and they draw in their book a row with 2 groups of 6, and they write next to it the number 2 times 6, or 2 groups of 6 equal 12. And teaching conceptually that helps them make that connection between the concrete, where they're actually touching and grouping and doing, to seeing what the groups could look like if they didn't have the resource, to actually moving towards understanding, oh, that's why 6 2s are 6 or 2 6s are 12. That's why, because it's 2 groups. You see, and you're also preparing them to work with sets for when they get to secondary school. But I also have that concern that as I had made the point about people wanting children to learn things by rote. It has its place. That's how we learn. But you learn something by rote when you understand what the thing is. Teach the concept first and then identify patterns, because when you put those groups of 6 together to build your tables, you're seeing a pattern. You skip counting in 6, because many times we practice skip counting in primary schools, right? So you're using that skip counting to build these sets, to move from the sets to the tables. So there's nothing wrong with having the tables on stuck on a desk, except when they go into the SEA exam, that high stakes exam, and have no tables on the desk. And that's where the problem is, that we want them to be able to write SEA in standard 1. No, they need time to learn the tables. By the time they get to standard 5, you would have drilled them, because you would have taught them the tables properly. And so by the time they get to standard 5, they don't need any counters. They don't need to have it stuck on their desk, because they have seen the pattern and they can skip count. They can group and they can pull things from memory more readily than if you hadn't.
So thank you very much for that. I now have 2 questions, so let me find them for you. Okay. From Mary Budu Singh, we have working out lapse time is an issue for my 9-year-old granddaughter. I use a clock, but it's still an issue.
Not sure what lapse time means. I mean, the time between something starting and something ending? Is that what
Maybe Mary, you could just type that in your Q&A. I think she means like you know, if something is going to go to take a certain amount of time, she's not able to judge that. Like, we're going to do this in 10 minutes.
Right.
But I'll go on, because I'm going to ask Mary to go into the chat again to express what she meant. So let's go on to the next question, which is from Michelle Calawan. How do you get kids to know when to multiply or divide when doing word problems? Yes, this is something.
Yeah. So I had shown a picture where there was a chart with the different operations and some keywords. And so some research says that you teach them keywords, so when they see sum or all together, they know it's add. The problem, though, is that sometimes the word altogether does not mean multiply, but it might mean, sorry, it does not mean add, it might mean something else. Yeah, so I would say for those who are struggling, go back to the explicit instruction, use the schema-based instruction so that they are able not just to learn one sum and work it out, the next sum and work it out, but they can compare what different word problems say. That you spend focused time analyzing word problems. So sometimes it's teachers want to work out the whole word problem. But if your focus is analyzing the problem, then have them analyze 3, 4, 5 problems, look for the patterns, and then you do the computation. Because more likely than not, you had taught them the computation anyway, the arithmetic anyway. They can quickly pick up the arithmetic. The problem is that they are having difficulty analyzing the problem, the question in front of them. So I would say using schema-based instruction, giving multiple examples of the same type where they can identify patterns, how things are worded, and developing that schema for each type. Schemas for multiplication problems, schemas for division problems, so that when they encounter one, they already have learned the schema and they're more likely to get the right schema and choose the right strategies to solve them.
Yeah, I have 4 more questions, it looks like, coming up. It's lovely. How do you recommend teaching ascending and descending order?
Yeah, so I would say conceptually as well, using those concrete manipulatives. I think that when we have taught children about number, and number is a very abstract concept. We think that that thing I showed that was 27, we think that that's a number. That's not a number, that's a numeral. That's a symbolic representation of a group of 27 things. And so we often think that when we teach children the word or the symbol for a quantity, that they are able to do things with them. So they can arrange numbers in ascending order or fractions in ascending order. But as I had said before, they come to school from a life where they are playing with things and with people, they're sharing between themselves, among their friends. They have had many experiences with math by the time they come to school. And so we have to, especially when they're young, continue with the concrete manipulatives. The problem that teachers always complain about is the time, right? They have a test at the end of the term. They have to write the same test as the other standard 1. Everybody have to write SEA in standard 5. So ascending and descending order means that that child has conceptually understood what 5 is, that 5 is 2 plus 3, and 5 is 1 more than 4 because 4 is 2 plus 2. So from that concrete stage, when a child has understood what number is from that concrete stage, then they're able to do things like arrange an ascending or descending order. And there's nothing wrong with having them use the manipulatives. We used to have, I remember having, what's the Chinese abacus, and abacus when I was in primary school, and I used that all the way up to standard 3 or standard 4. But we think that exposing them to that is just, too much. It takes a lot of time, that's the truth. Teaching conceptually takes a lot of time, and we are often very conscious of parents and principals and so on coming down on our backs, for that. So I would say try using the concrete manipulatives, have them draw it out and really understand conceptually, because numbers can be broken into groups, and build that relationship between 5 and 7, as 7 being 2 more than 5, that kind of thing. I see that there's a question about Jean Piaget's theory. Let me just find it back so I could read it. I think I'll have to do a search. Is there anything else? Okay,
yes, well, you got it?
Yeah,
okay.
I found it. Somebody had asked for Jean Piaget's theory. His definition of a schema is a cohesive, repeatable action sequence possessing component actions that are tightly interconnected and governed by a core meaning. In other words, a schema is like a big plan. Like if you imagine a concept map, all these things are tied together in a particular way. So it's a whole. It has individual pieces, but it's one whole structure, right?
I'm sure if you couldn't get that all down, you could just Google that and you can get that definition quite easily.
That actually, yes, is where I found it.
Okay, there's just a question about whether we would be sending on the links so that I know that you had said that you would send
Yes.
us, and we will
Yes.
send.
Yes.
Dr. Jagannath is going to be sending us some handouts, and we'll send it to all of the participants. So you will definitely get that. There's a comment here in the chat. It says, if we know children with math learning difficulties have issues with working memory, this would be an issue for them to pull from memory, or maybe from memory. Children with math difficulties should be allowed to use timetables, facts charts, so that it doesn't hinder them from further learning, which we talked about.
Yes.
Absolutely.
And problems with working memory, you can really, only a psychologist can tell you that that's what the problem is. You can think that based on what you're seeing that they're having problems with working memory, but if you're not a trained professional, you wouldn't know. I wouldn't know what that looks like either. I know what some of the symptoms of dyscalculia are, but I can't say that it's because of working memory. So a professional will need to interact with that child to tell you where their problems lie. And as I said, there isn't a test that I know of for dyscalculia as there is, well, many probably for dyslexia, but in an assessment for one of those other learning problems, you can actually identify. I've interviewed 5 people who dyscalculic, and they all were assessed for things other than dyscalculia, but it emerged as part of their results, the assessment results.
Thank you. And then Mary Budu Singh, who asked about the lapse time, corrected it to elapsed time. Does that make more sense? She has, her daughter has difficulty.
It sounds as if Mary's asking, she's asking about how you take away time, maybe like if something starts at 3:10, how many minutes if it ends at 4:20 or something like that. Again, conceptually understanding, because time does not use our base 10 system, and we use base 10 all the time. Everything we count is in base 10. So for a child to remember, to move away from that base 10 and remember 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day, there's no consistency. And so it really just takes practice, teaching conceptually, using graphic organizers, using manipulatives, using the clock, and having a clock where you actually draw out every little minute stroke, every second stroke on that clock, the minute stroke, and have them actually count. You know, even telling time is difficult. We expect children to learn how to tell analog time so easily, and they're on the computer now all the time. They know how to read digital time. Analog time is a complex concept, and telling time is complex. So I would say that you would have to use a multicentury approach, a CRA approach, and do it conceptually using those resources.
Thank you. I've got two more here. I think we have time. One was just making a comment about the Singapore math model, and what do you know about that? Because this person thought it would be interesting if our curriculum and timetable reflected that methodology, Singapore math method.
Our curriculum, sorry, ask the question again.
It's just they were just making a comment. It wasn't a question. It was a comment about
the Singapore math.
A lot of the organizers you discussed were also used in the Singapore model, and she just thought it was interesting. It would be interesting if our curriculum could reflect Singapore methodology. So
you know, even with the Singapore model, not all children responded the same way. It's just a different approach to doing the same thing. You know, and the way it's packaged might be a little bit different. It might be a little bit more polished in some areas, but children learn differently, and not everybody, we can't just wholesale adopt the Singapore method, because not all children learn the same way, and there are children who don't respond to the Singapore model at all. You know, so and of course, we can't just adopt, and I think that has been our problem for too long. We just see something outside, it look pretty and shiny, and we adopt it here. There are contextual issues that interfere when we try to adopt things wholesale. You know, our society is not like Finland, it's not like China, it's not like Singapore. Our education system is different from them, even from other Caribbean societies. Ours is different. We write the same regional exam, same CXC exams, but our education system is different. You see, so we can't just go around willy-nilly choosing things and adapting them, or importing them, adopting them. You can adapt some of what you do to include, for some children it will work, so include some of the Singapore approaches. Yeah. And somebody's just posting that the education system doesn't provide for children that learn differently, and that's absolutely true. There's one curriculum for all children, and the curriculum gives a number of suggested strategies, and some of them don't work for children who are struggling. And so we have to look elsewhere. And that's what happens when you are trying to be generalist, because the curriculum is generalist. You are trying to cover your bases and meet a minimum level of proficiency kind of thing, to make sure that at least everybody could get there, but everybody can't get there. There are different things that happen. People have different experiences that affect their interests. They're exposed to different things in the home. Some homes are filled with lots of conversations about different things. Some families travel a lot around Trinidad and Tobago, a lot around the world, and so they bring different experiences to the home. So in some homes, children don't play. They just go from lessons from piano to maths to something, you know. So people's experiences are different, you know. I wish I could read some more of the chat comments.
Well, I got a
they
really
just
nice
find-
one is Nicola Abraham, who I know is a math teacher and specialist math teacher. She just reiterated concrete in capital letters, pictorial, abstract. And I remember first hearing that even secondary school students are not always ready for abstract. And as you said, age 14 realizes that late.
Yeah.
So you really need that concrete and those manipulatives. And somebody had a wonderful suggestion and said, you know, those beads are thrown away in mass camps. Go and
Yes,
Vietnam. So
absolutely.
Pick up on Lego blocks. You can pick up manipulatives and make your own and cut out circles into fractions and teach adding fractions like that. So, I mean, I don't teach math, but I'm fascinated by it. And
But Catherine, there's so many things that you can use from around the home. We throw away bottle corks all the time. We buy blue waters. We buy all kinds of different soft drinks, chubby juice, all kinds of things that we can actually use bottle caps from. You know what I mean? We have buttons. You don't have to buy things. You can use paper clips that are different colors, different sizes. You know what I mean? So we are falling short by not looking and capitalizing on what we have. You know, we can't always find something on Amazon. There's some things that your children and you can make in the classroom. You know, I did an exercise with some primary school teachers in training to make a set of tangram, but I didn't give them the picture and have them cut it out. I gave them instructions. So we went along, it was about folding, and they had to follow my instructions to fold and cut. And I had about 100 steps. And some of them struggled to follow my instruction because they didn't understand what I was saying. You know, so the point about that, though, aside from the communication, is that we can make things with our students together. They have a set, I have a set. You know,
I think we have a feeling that our children are manipulating. They're playing, and there's
nothing wrong with play.
It's learning, yes, yeah. Yes.
That's how they learn which one big and which one smaller. They play. Who's swinging higher on the swing? It's play. Who can run fastest? In play. They're learning about time, about distance. You know, yes. When they move over into the classroom system. The classroom, we tend to feel, right, it's time to settle down, and we have them sitting in rows or benches in rows, and they're all sitting together. They all must keep up at the same pace when we know that their interests are different. In the same family, you have an artist and a doctor and a historian. You know, what drives them towards those careers? Because their interests are different. And when they were born into the family, they were exposed to different things, you know, so.
Yeah, we're almost time to end, but there's an interesting comment here where someone says that, I think Nicola, she says that I don't think it's the access to manipulatives that's the problem. It's that we weren't taught with manipulatives. So we need retraining to teach with manipulatives. And that's why I know UE school.
But you know, I have to say, I have to disagree with that. I have to disagree because I have colleagues who taught in the teachers' colleges.
Yes.
And they talk about when they used to have their teachers in training make manipulatives. So I don't agree with that 100%. Maybe when the teachers' colleges closed, the batch of teachers that are saying that maybe didn't have that experience. But when I work with secondary teachers who have taught in the primary system, the ideas that they come with and the resources that they have designed and access are really creative because they learned that in training college. So I'm not sure that I agree with that 100%.
Of course, there are teachers who do and teachers who don't. So
yeah, yes. I think that what has happened over time is this focus on winning scholarships starts in preschool. So you go to a certain preschools, you get into a certain primary school, which is a feeder school for a certain secondary school, which is a feeder school for the 100 scholarships that we now have, 100 out of thousands of children, you know. So until we let go of this examination curse, we will continue to struggle and children will fall by the wayside. Not just math, they're falling down in. So when a school, children from a school, 16 children from one school earn a scholarship, what about the other 80 children that didn't? What about the 15 that didn't even pass the exam? You know, we don't think about how those children fall through the cracks and what happens to them, because they become parents with children who struggle and they can't help because of the self-esteem and the math anxiety and all the other things, you know. So it's not so easy to bring Singapore maths here. There's so many contextual issues that work against anything that is brilliant, but we can adapt parts of it in small ways in our own classrooms, you know. We change the world one child at a time.
Okay, before we end, I really have to answer this